Welcome to the Explainer. Today we are diving deep into one of Python's absolute cornerstone features, classes. You know, if you've ever wanted to really organize your code, to build your own custom data types, and truly level up how you think about programming, well, you're in exactly the right place. We're going to pull back the curtain on Python classes and turn you from someone who just uses code into a true code architect. All right, so here's our game plan. First, we'll talk about why we even need classes to begin with. Then, we're going to get our hands dirty and build our very first object. After that, we'll see how to make it more specialized using something called inheritance. And finally, we'll peek under the hood to see how Python handles names, and then explore the real magic of iterators and generators. It's going to be fun. Okay, first up, let's tackle the main problem that classes solve so elegantly. It really all boils down to bringing some order to the potential chaos of just having data scattered everywhere. So just imagine you're trying to keep track of a dog's info. The messy way, well, you might have its name in one variable over here and a list of its tricks in another variable over there. I mean, sure, they're related, but in your code, they're just kind of floating around completely separate. A class lets us do this the clean way. It allows us to bundle that related data, the name, the tricks, and any actions like teaching a new trick into one single neat package. And that right there is the big idea behind classes, bringing data and functionality together. So what is a class, really? The best way to think about it is like a blueprint for a house. The blueprint itself, not a house. You can't live in it. But it defines everything about a house, the number of rooms, the layout, you name it. In the world of code, we call the data items attributes, and the functions that operate on that data, we call those methods. Now, the cool part is, from that one blueprint, you can build as many individual houses as you want. And in programming, we call those houses objects or instances. All right, enough theory. Let's actually see this in action by building our very first object. It's time to take that blueprint we've been talking about and bring it to life. And to make all these concepts really stick, we're going to use a simple dog class as our main example for this whole explainer. This is going to help us see exactly how these sometimes abstract ideas work in a very practical way. Now, whenever we build an object from our class blueprint, a special method called __init gets run automatically. You can kind of think of this as the object's constructor. Its whole job is to set up the initial state of our new object. So for our dog class, this is where we'd give each new dog we create its own unique name. And that first argument, self, that's just a standard convention. It refers to the new object itself, giving the method a way to attach data to it. So what's really happening behind the scenes when you do this? It's actually a pretty simple three-step dance. First, you call the class, almost like you'd call a function. This tells Python, hey, create a new empty object for me. Then, Python automatically calls that __init method on the brand new object to set it up. You know, like giving our dog the name Fido. And just like that, the fully formed object is ready to go. Okay, this next point is absolutely crucial. It's a trap that trips up so many developers when they're first starting out. The question is, when you define a piece of data, an attribute, does it belong to the blueprint itself and get shared by all the objects, or does it belong to each individual object you create? Because the answer to that has some pretty big consequences. And this right here shows you exactly what I mean. It's a critical difference. On the left, if we define tricks at the class level, every single dog instance we create shares the exact same list. So if you teach one dog to roll over, all of a sudden, they all know how to roll over. To fix this, you look to the right. We create self.tricks inside the init method. This makes it an instance variable, which guarantees that every dog gets its own personal list for its tricks. This is totally key for any data that needs to be unique to each object. So once you've got a solid blueprint, you don't have to start from scratch every single time. You can create more specialized versions of your classes using a really powerful concept called inheritance. Inheritance is pretty much what it sounds like. A new class, which we call a derived class, inherits all the features from an existing base class. This is fantastic because it means we can reuse code. You could have a general dog class and then create a more specific service dog class that inherits all the basic dog behaviors, but then adds its own special skills without having to rewrite any of the original code. And here's where it gets really flexible. The new class has two powerful options. It can completely override a method from its parent. For example, maybe a poodle class has a different, fancier bark method. Or it can extend the parent's method. It can do its own special thing and then call the original method from the base class to do the rest of the work. It gives you incredible control. Okay, to truly master classes, especially inheritance, we kind of need to understand how Python keeps track of all the names we're creating. Our variables, our functions, our classes. And this brings us to the ideas of scopes and namespaces. A namespace is really just a system that makes sure all the names in a program are unique so they don't clash with each other. The easiest way to think of it is like a dictionary, where the keys are the variable names and the values are the actual objects they point to. Every single module, function, and class has its own private namespace, which is why you can have a function called update in two different files without any confusion at all. So when you use a variable, how does Python find it? It follows a very strict search order. First, it looks in the L local scope, right there inside the current function. Not there? Okay. It then checks any E enclosing function scopes. Still no luck? It moves up to the G global scope of the whole file. And as a very last resort, it checks Python's B built-in names, like print or len. It's kind of like looking for something in a set of nested boxes. You always start with the smallest box and work your way out. All right, for our final section, let's explore two slightly more advanced features that make your objects incredibly powerful and feel really Pythonic. We're going to make our custom objects work seamlessly with for loops, which is essential for writing efficient code that can handle tons of data without gobbling up all your computer's memory. Have you ever wondered how a for loop just knows how to work with everything, like lists and strings and dictionaries? It's not magic. It's a really simple, elegant system called the iterator protocol. Here's how it works. The for loop first calls an itr method on an object. That method returns an iterator. Then the loop repeatedly calls the next method on that iterator to get each item, one at a time. When there's nothing left, next raises a special exception, and the loop knows it's time to stop. And the best part is, you can add these two simple methods to your own classes to make them loopable too. But here's where Python really just shines. We can get the exact same result with something called a generator. Look at the difference. Instead of a whole class with multiple methods, we just have a simple function. It uses the yields keyword. This keyword is amazing. It basically pauses the function, hands back one value, and then perfectly remembers its state for the next time it's called. It is so much cleaner, it's shorter, and frankly, it's just a lot easier to read and understand. And for the simplest cases, it gets even better. Generator expressions are the ultimate shortcut. They look almost identical to list comprehensions, but they use parentheses instead of square brackets. And that small change makes a huge difference. This doesn't build a whole list in memory all at once. Instead, it creates a generator that produces values on the fly, as you need them. This is incredibly powerful and memory efficient, especially if you're working with, say, millions of lines from a log file. So, what a journey, right? We've gone from dealing with scattered, messy variables to architecting our own structured, powerful, and even loopable objects. You now have the blueprint for building your very own data types in Python. So the only real question left is, what amazing things are you going to create?